Good morning to everyone. Myself Sanjay Mavinkere Rangappa. I'm a senior research scientist and associate professor and also an advisor within the Office of President for University Promotion and Development towards international goals at Himapur University of Technology, North Bangkok, MUTNB, Thailand. Before my presentation, I would like to thank Professor Dr. Femina Sari from Sanjay University for our kind invitation to join this 2022 Sanjay University Conference BAC as an invited speaker. I extend my thanks to the conference committee members and Sanjay University. My presentation topic is sustainable natural fibers as reinforcement materials for composites. As we know that if natural fibers as a reinforcement materials in composites, then we can call them natural fiber composites. And natural fibers are nothing but fibers which are derived from natural resources like plants, animals, or some other living species. For example, jute, kenaf, sisal, bamboo, banana, etc. are the natural fibers that are extracted from plants. On other side, wool from animals, feathers from birds, these are all some other natural fibers. Now I am going to present general highlights of natural fiber composites. As we know that recently the environmental impact of synthetic fibers has inspired scientists to focus on using natural fiber as a reinforcement material in polymer matrices. The recent extensive studies and development efforts has directed that natural fibers, as I mentioned earlier, such as jute, sisal, kenaf, bamboo, banana, etc., can replace synthetic fibers like glass fibers and carbon fibers. Most important, the natural fibers are abundantly available resources in all countries, which are cheap and easily renewable and even biodegradable. Another important highlight is natural fiber reinforced composites are reasonably strong, lightweight, and biodegradable. Hence, they have the potential to be used in several applications. Also, the use of natural fiber composites in industries has steadily increased. Recently, it is steadily increased, benefiting fiber plant production and world's economy, which means it will be indirectly helpful for our farmers and agriculture. So, recent developments in natural fiber composite studies have illustrated the great potential as structural components in various applications. See this figure. It has represented the number of publications based on materials composed of natural plant fibers between 1997 to 2019, found in Science Direct using the keyword natural plant fiber composite. And each year there has been a steady increase in the number of published work. So that means natural fiber composites is one of the notable research area for development of eco-friendly materials. This slide presents factors which are affecting the performance of natural fiber composites. This slide especially for upcoming researchers. See, based on these factors and parameters, the upcoming researchers can identify new research works on natural fiber composites to develop sustainable and eco-friendly materials. First factor is selection of natural fibers based on the parameters such as type of fiber based on its origin. That means the fiber derived from plant fibers as I mentioned before, such as canaf, jute, sisal, etc., or comes under plant fibers. Animal fibers such as wool, hair, feathers from birds, or mineral fibers like basalt fibers, even geographical locations based on environmental conditions, harvesting time, chemical composition. That means chemical composition of natural fibers such as cellulose, hemicellulose, lignin, extraction method, chemical treatment and fiber content, surface topology, fiber size, fiber length. Even we can do the new research based on the properties of natural fibers such as density, hardness, thermal properties, modulus, strength, elongation at break, etc. Fiber dispersion in composites depends on bonding between fiber and matrix. As we know that fibers are hydrophilic in nature, and that means natural fibers are hydrophilic in nature and matrix is hydrophobic in nature. So chemical modification is the only solution to reduce the hydrophilic nature of natural fibers. That means that will be helpful to increase the bonding efficiency between fiber and matrix in composites. Even we can also do the work on orientation of fiber to improve the properties of natural fiber composites. Other factors such as matrix selection like thermoset, thermoplastics, biopolymers, composite interfacing properties, also consider for even composite interfacing properties also considered for improvement of performance of natural fibers. We can also do the work on composite processing method and composite characteristics. Now I'm going to explain performance and durability aspects of natural fiber composites by using noteworthy results of my own publications. And this research study, the extraction and characterization of waste fibers from water icing plants, and also the fabrication of bioepoxy based eco-friendly composites from chemically treated water icing fibers. And we know water icing is an aquatic plant collected from here near Chom Prai River, Bangkok. Here in this research, the water icing fibers are chemically treated by NaCOH, means sodium hydroxide, and silane solution, and bioepoxy as a matrix material for making composites. The raw NaOH and silane treated water icing fibers reinforced bioepoxy based composites are manufactured by casting method. Then different tests were carried out on prepared composite specimens. Especially this research revealed that the composites made by chemically treated fibers, either from NaOH or from silane solution, have better results when compared with raw fiber reinforced composites. This study confirmed that water icing fibers can be used as a reinforced material with bioepoxy polymer to develop fully bio-based eco-friendly composites for production of lightweight structures. This is the one work. This another work. This investigation is an attempt to develop of sisal fiber from fabric reinforced bioepoxy hybrid composites, and we assess the performance of composite under isolated weathering conditions. The bioepoxy resin and Knauf sisal fiber fabrics were used for making hybrid bio-based composites and manufactured composite laminates using compression molding method. For comparison purpose, a neat bioepoxy thermoset was fabricated by casting molding technique. To promote the accelerated weathering of composites, the samples were exposed to environmental conditions such as ultraviolet radiation, extreme temperature and humidity conditions in accelerated weather tester machine according to STM G155 13 cycle 1. The tensile impact morphology, TGA, DMA and water absorption test were performed for both before and after weathering test samples according to international standards. From this research, the results indicated that the manufactured fully bio-based enough sisal fiber reinforced hybrid bioepoxy composites show moderate properties when compared to neat bioepoxy composite at both before and after weathering condition. That means reinforcement of natural fibers in polymer composite can increase the properties of composites. Also, from the result, it is worth to point out that these fully bio-based composites are promising composite material for semi-structural applications. This investigation is an attempt to assess the hybridization effects of different laminate stacking sequences involving jute enough e-glass over fabric. The composite laminates were fabricated using vacuum bagging method. This study reveals that the vacuum bagging method is a very effective method to prepare composites with low void volume fraction. The tensile properties of composite laminates were influenced by the strength and modulus of fibers. And the tensile, flexural and hardness properties of composite laminates mainly depend on the sequence of high strength fiber lies in the laminates and also influenced by stacking sequence and adhesion levels of fabrics. It is also noted that the hybrid laminate having glass plies as skin layers and natural fiber plies as a core layers showed better tensile, flexural and hardness properties. Also from SEM analysis, scanning electron microscopic analysis, it is evident that the good composite properties are depend on the presence of fewer voids and proper adhesion between fiber and matrix. This research investigation on development of composites by flask basalt carbon fiber reinforced with both bioepoxy and synthetic epoxy under different stacking sequence techniques. These composites were fabricated using a manual and layup method and compression molding technique. This investigation revealed that the hybrid laminate having basalt fiber, that means mineral fiber, or carbon plies, means synthetic fiber, as a skin layers and natural fiber plies as a core layers showed better tensile, flexural and hardness properties. From this research, it is also noted that the mineral fiber, that is basalt fiber, also viable material for replacement of carbon or any synthetic fibers. This research investigation intends to recognize the effect of laminate stacking sequence of natural fibers, e-glass, carbon fabrics, reinforced hybrid epoxy composite. Here we have used one natural fiber and two different synthetic fibers. And manual and layup method is used as a fabrication method, while studies on physical, chemical and morphological properties has been conducted in this research work. From the results obtained, it is obvious that the properties of natural fibers, e-glass, carbon fiber reinforced epoxy composites enhanced due to the hybridization with that means the properties of composite will be increased by addition of either e-glass or carbon fabrics in natural fibers. This work based on performance of hybrid composites improved by using different natural fibers and adding particulate fillers to them. In this study, we studied the mechanical and tribological properties of jute, sisal, e-glass fabrics reinforced with a matrix such as natural rubber and synthetic epoxy and filled with different proportion of tungsten carbide powder WC powder. Research revealed that there is a significant change in the mechanical properties and enhancement of wear behavior was noticed due to the incorporation of filler particles. That means filler loading can increase the mechanical properties and decrease the wear rate by increasing the bonding property between fiber and matrix. And this investigation was performed to study the effect of titanium carbide (TiC) nanoparticles and coir fiber as hybrid reinforcements on physical, mechanical and thermal stability of coir fiber incorporating with titanium carbide epoxy composites. This work proves that the incorporation of TiC, that means titanium carbide nanoparticles in coir fiber epoxy composite, exhibited some improvement in mechanical characteristics. Application of natural fiber reinforced composites. This figure shows some of the applications made by natural fiber composites. Hybrid composites, that means natural fiber with synthetic fiber, find their applications in automobile and automotive sectors like in the production of car interior parts, doors, headliners, decking, dashboards, pallets, spare tire covers, seat backs, spare wheel panels, etc. They also may be used in household applications such as chairs, lampshades, roofs, suitcases, tables, bath units, etc. In the marine field, they find applications in the manufacturing of boat hulls, fishing rods, etc. In the sports sector, they are being used in the manufacturing of tennis rackets, bicycle, sports helmets, etc. And they are also utilized in manufacturing of storage devices like post boxes, grain storage silos, and biogas containers. I'm requesting audience to refer my recent review articles for more information on natural fiber composites. I'm happy to say this, most of my review articles are most cited articles in top journals. And now I'm presenting observation and knowledge gaps based on my literature survey on natural fiber composites. Most of the researchers used hand layup and compression molding methods for preparation of composites. So upcoming researcher can do research on effects of various manufacturing processes. Recent researchers has been focused on the impact of stacking sequence and hybridization of synthetic fibers with two or more natural fibers to increase the properties of natural fiber composites. The hybridization of natural fiber composite by another natural fiber does not yield superior mechanical properties as compared to hybridization by synthetic fiber. And one of the most important challenges facing researchers today is to achieve a better interfacial bonding between natural fibers and polymers. But this is quite difficult due to hydrophilic nature of natural fiber and hydrophobic nature of polymers. But chemical and surface treatment to natural fibers are better solution to overcome this problem. Composite materials reinforced with natural fibers are best option to replace synthetic fiber composite, at least for low load applications. Researchers substantiated that the materials made from renewable sources such as natural fibers embedded in a matrix of polymers called biopolymers offer as good alternative to synthetic fiber composites. These are all my books published in Elsewhere, Sprinter, Ville, CRC+. As of now, I have published 28 books. If any point of queries and collaborations, please contact me by email. Surely I will address those emails.